Welcome to log practice questions. So this first question here was a Regents question, and they want you to graph the equation on the step below. And the key word here is that they're asking you to use an appropriate scale to include both of the intercepts. That means that you're going to have to scale your your axis somehow, and you can't just count by ones. So when we go and put this in the calculator, we go to y equals, and again, to get the log with a special base, you're going to hit alpha, window, choice 5, log base. When you go to graph this, you'll notice that on your standard 10 by 10 grid, you won't see your x-intercept, right? You only see the y-intercept. So that's why we have to scale our graph that we see both of them. If you go to your table, first of all, you'll notice that at -3, you have your asymptote. So definitely keep in mind we're not going past that value on our graph. If you continue to scroll down, you want to look for where your y values go from negative to positive, because that means you're going to cross over your x-axis. And that happens finally at 29. So you need to make sure your graph goes from 0 to 29. In order to do that, you can choose whatever scale you want. I don't suggest going by threes because you'll get to 30, but that's so close to 29. So you can count by fives if you wanted to. Just keep in mind, if you count by fives going on the right, you have to count by fives going on the left as well. You can't just change your scale like automatically. So you have 5, 10, 15, and so on. And then the other direction, you're going to have -5, -10, and so on. Your y values, because we already saw the y-intercept on your basic 10 by 10 grid, you can just count those normally. That you can count by ones going up and going down. Now, if I were you to get partial credit, just in case you mess up, I would always write down all the table of values that you're going to plot. So once you have all your values, you're going to plot them. Keep in mind that -5, it says error, because you know that your asymptote is at x equals -3, right? The whole graph was shifted to the left by 3. And you can actually see that in your graph. Again, I think so go to -3 and put down where you think your asymptote is. And then from there, you're going to plot all the points and connect them. Make sure you don't touch your asymptote. Make sure you include arrows because there's no domain. And make sure that you actually label your graph. So we have y equals log base 2 of x plus 3 minus 5. And you're done graphing. Now, to describe the end behavior of the function as x approaches -3, this is kind of like how we normally write end behavior. Instead of actually using symbols, they just wrote it out. So they're basically asking, as x approaches -3, that's your asymptote. What's the graph doing? And if you look at the graph, as you're approaching the asymptote, you're heading down. So you're going to say that y, usually we write f of x goes towards, but in this case, we have y as our equation, right? Not f of x. So I'm going to write y approaches negative infinity as our answer. Now they want you to describe the end behavior of the given function as x approaches positive infinity. Positive infinity is on the right. So on the right side of the graph, what is it doing? And it's going up forever towards positive infinity. So y approaches positive infinity is your answer. Let's try some multiple choice questions. So we have practice problems. This problem is telling you that the growth increases logarithmically, and they want you to know which graph it follows the pattern. Just looking at all these graphs, the only one that is a log function is choice 3. Choice 2 is exponential, and choice 1 and 4 are linear. Choice 2 is a little more deceptive. If you read this problem, they want you to sketch which best represents the graph, and at first it looks like an exponential equation, right? But what's different about this problem is that your x and y values are switched. And if you think about it, when your x and y values are switched, that's a good indication of you starting to find the inverse. So it's not asking for which one's an exponential function. They're asking for which one is the inverse of an exponential function. And that means they're asking for a log graph. And the only one that's a log graph is choice 2. For number 3, if you're translating a equation, your best bet is to write the translated function out first. So we're going to the right by 1, which means we have to subtract 1 inside the parentheses, and going down by 1 means you subtract 1 going outside of parentheses. So we have y equals log base 2 of x minus 1 inside parentheses to show that you are going to the right. And then we're going to have minus 1 on the outside to show that we are going down. You're going to put that in the calculator, and you're going to see which coordinate is your answer choice. And if you look at the graph, or rather the table, you'll see that they have the coordinate 3, 0. For number 4, they're asking which one is the inverse of a log function. And the inverse of a log will always be exponential, which means you can cross out choice 3 and 4 because both of those are logs. Now, your base of the log is 4, which means the base of your exponential should also be 4. For number 5, they want to know what quadrant it lies in. Always double check with your calculator to make sure that, just in case translations came into play, that the quadrants were switched. But anytime you have a parent function of a log equation, that means no translations going on, you're always going to start in the first and fourth quadrant. Quadrant 1, 2, 3, and 4. So that's going to be choice 4. 6 is asking for the inverse, and they're giving you an exponential, which means that the inverse is a log. Which one looks like a log? Only choice 3 does. 7, be careful. They want to know which one is false. If they give you an equation, your best bet is to put it on a calculator and look to see what exactly is going on. You also need to know that there's an asymptote here, right? And that asymptote is going to be x equals 0. So log functions have asymptotes of x equals 0, whereas exponential functions have asymptotes of y equals 0. So this is for an exponential function. For logs, it should be x, and that's why the first one is false. The graph doesn't have a y-intercept because of the asymptote. The domain is the set of all positive real numbers, right? Because the positive values are anything greater than 0, which is what we have. And the range is all real numbers. Because there's no restrictions on it going up or down. So for number 8, they're asking for the domain of the log function. Because you have x plus 5, that means that you're shifting to the left by 5. That means your asymptote is going to shift to the left as well. So if you think about it, your asymptote of a log function is down the middle, right? But it's going to shift to the left by 5. That's going to give you x equals negative 5. Your graph is going to be to the right of that. So your domain is anything that is greater than negative 5. Now that's if you think about it algebraically. If you think about it graphically. If you want to think about it algebraically, you can just know that you can never get a negative value inside the parentheses of a log. So for example, why negative 6 won't work is because if you had negative 6 plus 5, that gives you a negative value inside the parentheses. And that's no good. If you try to put that in your calculator, log base 3 of negative 1, your calculator will tell you error. So that's definitely not good. If you don't want to do this by thinking about the graph or by thinking about it this way, your other option is to put it on the table. If you were to put the equation in the calculator, on your table, you're going to see the coordinate negative 4 comma 0, but you'll also see negative 5 and error. Because negative 5 is the first one that gave you an error, that's your asymptote, and that's going to be where your domain starts. And finally, the last one of number 9. They give you an exponential equation. They mention the word inverse. So that means the inverse of an exponential equation is a logarithm, which is choice 2 because 1, 3, and 4 are all exponential equations. And that's all for this video. There's a whole bunch of practice here for multiple choice questions on logs.